Alright guys, quick disclaimer. The airsoft replica and or parts in this video are not real firearms. And nothing shown works in real firearms either. So don't try it. This video is for educational and entertainment purposes only. And everything here is strictly for airsoft use. Again, these are airsoft use only. Alright, let's get into it. Welcome back guys to another new episode of a WishTech build. So we're going to be doing a CYMA REC10 build, but before we get to all the upgrades and all that good stuff, we're going to do a complete breakdown in this video. First things first, we'll get our chrono. We'll get a chrono with 40 gram BBs using my personal favorite HPA 4.0s, so we get the most consistent FPS possible. Doing that, we'll get our baseline, and then we're going to tear apart this thing and see what's inside and talk about what the internals are and give you guys my personal opinion, as this is supposed to be a much lighter and a little bit cheaper version of the CYMA SR25 Platinum Edition. Should have very similar internals, but this one in particular has the shooter ETU, which in my opinion is much more reliable than those pesky Zeus ETUs that they usually have in these SR25s. And after we get it all torn apart and stuff, and then I'll finally show you guys what parts are going into this bad boy. You don't want to miss that because there are some goodies going in this. This is a customer's replica, and we are pretty much going all out with this thing. The goal is 2.4 joules on 40 gram BBs. That's why we're testing the baseline with 4.0, so I can show you guys before and after when we do the after chrono at the end of the video. And if we have time, then I might just do a range test with my run cam. So with that all being said, let's go ahead and get started with the baseline chrono. Alright, so I plan on doing 10 shots in semi. We've got a joule rating up here with 40 gram BBs displayed here, and then of course our FPS. And then once we get to that part, I'll scroll over here and we'll get our overall FPS consistency, or our max, minimum, and averages. Ready, tighty, lefty, loosey. Got 4.0s in the mag. Here we go. Yep, we're getting about 1.24 joules on 4.0s, which is no surprise there because the barrel is way too long for 4.0s, first of all, because of air volume ratio. But anyways, let's see what our consistency is. Man, it's not bad. It could be better, but there are parts in this replica that later in the video we're going to swap out to make it way more efficient with 40 gram BBs. So let's head on over to the bench and tear this sucker open and see what we find. Oh, and by the way, before we do, I am using the 7.4 volt LiPo, and I'll explain on why on the bench. So why 7.4 LiPo? Well, in most SR25s, including A and K, and anything with a 19th tooth stroke of the piston and sector gear, creates more time that is needed for the piston to reach all the way to the forward position. If you use 11.1, you increase the risk of what's called premature engagement. That's where, if you don't already know, it's where the piston's traveling forward, going, and then the sector gear comes up early and engages like here, or here, anywhere that isn't the pickup tooth here, in front of my thumb. That's considered PME, or premature engagement. And this is what ruins pistons and or gears. And using a 7.4, you slow down the cycle speed of which the sector gear that picks up the piston a little bit, just enough so that the piston gets all the way to the forward position. And one of the other things that slows down piston travel speed, using too light of a spring, or a jam happens where you get air pressure buildup and it slows down the piston because, you know, air pressure is going to fight against that spring and slow it down. Or using heavy BBs like 4.0s, because in my experience, the heavier weight BBs you go, the more air braking effect you have. So what ends up happening is the heavier BB you go, the more air buildup happens between the piston and the BB going out the barrel, because the heavier BBs require more air to push out the barrel. Without going into too much detail, that's basically what's happening. I use a 7.4, slow it down, so I guarantee that premature engagement isn't going to happen. But on the downside, using a 7.4, yes, it slows down your gear cycle speed, which in turn makes your trigger response a little sluggish. To combat that, especially if you're going to DMR and you want all 19 of those teeth on the piston, use precocking. What's awesome about this particular platform of SR25 comes with the e-shooter, so you can program that. Pre-cocking is where the piston's loaded up to the rear on every shot. So when you pull that trigger, the piston's released. And you can set wherever you want that piston to be. And it's even more important to have your cycle rate not go too fast, which I'll explain later in the video, when you use pre-cocking. Since we already know that the e-shooter's in here, I'm going to go ahead and tear apart this thing and see if there's anything different between this and the CYMA SR25 Platinum series. All right, I got to tear this open on the count of 3. 1, a 2, and a 3. Ta-da! Starting from left to right, we're going to go over every part. Still using a similar spring as the Platinum, so nothing different there. Spring guide is different. So on the receiver, it's no longer the type that you loosen up the buffer tube nut and then just unscrew the end of the tube here and then have the spring guide come right out like that. On this one, obviously it's not there. The spring guide comes out the back like any other AEG would. So it like literally fits in there like a puzzle piece.
Oh my.
Still a spring quick change with the addition that you got to take this out of the buffer tube. Speaking of the lower receiver, I did find a few things. One thing that I really like that they did is that the cams for the selector switch are on the receiver now, so you don't have to worry about them falling out when you pull out the gearbox. You just have to make sure your selector switches are on the same mode when you put the gearbox back in. So there is some downsides of this design. So one major downside that I saw with this receiver is that the mag release is proprietary. It's a 3-piece design and it's offset. So instead of it going straight through the receiver and going through the whole of the gearbox, it goes in, down, across, up, and then to your mag release itself. We were going to put a max ambidextrous mag release, but we can't because of this design. And as of right now of this recording, there is no aftermarket mag releases for this model that I'm aware of. It was a little tricky getting this thing apart without breaking it. So taking it apart, you had to take out the ambidextrous bolt release lever right here, and then go through this hole right here to the button to the set screw that is 0.9 millimeters. Once you get that out, you can go through this hole right here. You'll see the mag release pointing towards you like this. And in this hole is just another screw that holds this piece on. The piece that actually holds onto your magazine like this. Then you gotta kind of pop it up like this once the screw's out, and then they all both come out through the center of the receiver. Then you're left with the mag release spring right there, right by my finger. So that's how you get that out. Biggest thing is I wish they did make their actual mag release lever rotate like an ambidextrous, but it doesn't. It is fixed. They made the bolt release mechanism ambidextrous and the selector switch ambidextrous, but not the mag release. Makes sense. Anyway, the piston is exactly the same as the CYMA Platinum. Got your nice little backup O-ring to keep the piston head off the cylinder walls. Then your mushroom type silent piston head. There is a ball bearing, thrust bearing inside the piston. I totally understand why, but it does have a ported cylinder. So for those who want to use heavy BBs like .4s, you do need to get a full cylinder. But I'm pretty sure CYMA's intent was to make this more of a battle rifle. So in between CQB and mid-range, so like using 3.2 gram BBs, this port is positioned as if it was like a full cylinder of a 16 tooth stroke AR. This makes total sense why the 4.0's joules were so low. I'm willing to bet it was just losing joules going so heavy. Cylinder head hasn't changed at all. I didn't notice any differences. Matter of fact, the nozzle is still plastic with no internal O-ring still. I mean, that's a very minor change they could change by putting an O-ring in there. You can use heavier BBs because heavier BBs require more air pressure and it tends to bleed out the back of the nozzle when you try shooting 4.0s and above. But yeah, it still wobbles a bit. The tappet plate, still exactly the same. I didn't see any differences. This will not change in the build, but I'll go over the exact parts that are going in this build later. But this is honestly a pretty decent tappet plate. I'm actually giving some effort to flex this. So it's at the front here, this is almost a perfect 90-degree angle, which is what you want on your tappet plate. Pretty strong, but flexible. The cutouts here are there for the reinforcement that CYMA puts on the front of their gearboxes so the front of them don't snap. This is what makes these gearboxes so robust to 3 joules, or even all the way up to, I've even had these things survive 4 joules just fine. This reinforcement that they did on their shells is mint. You don't need a retro arms gearbox if it's a CYMA. These are damn strong gearboxes. The gears, make no mistake, their looks are deceiving. They have a coating on them, but they are still MIM steel gears. MIM, metal injection molded gears. How can I tell that? Let me show you. A close look at the spur. See those circles? Those are ejection ports from the die. And as you can see, they are labeled EMG, which is EVIC Manufacturing Group. They're decent gears, but I would not trust them on anything over 2 joules because these teeth are brittle. Sector gear is the same. Let you guys get a good look at it. 19 for 19 tooth. They're identical to the non-coated gears. Motor does seem to have neodymium magnets. It's definitely not weak like ferrite magnets, but I don't think this is a motor that you need to replace if you're trying to go on the budget side of things. It's an okay motor. I don't like the motor towers in these things because they do move around a lot in the base of the gearbox here, that little ring right there, and that can screw up your shimming and make it sound like poopy. Regular old anti-reversal latch. Nothing special. Still using that plastic hop-up, which makes sense for such a budget-friendly SR25. I do like that they have these locking lugs right here in front of my fingernail. Hop-up arm is the same. They have the little rubber piece that sits in there. Hop-up arm just grabs onto it so it doesn't move around, and it's very soft. So this is ideally for lighter weight BBs, definitely not for 4.0s. Here's the bucking, and I'll show you the nub that they went with. It's like a W shape, if you look in front of it. See right there, in front of my thumb. See how I can press down on the BB and center it up on each shot, so it should help with accuracy if you intend to use this replica out of the box as a battle rifle. It's great for that. But what I'm not really happy for is that the bucking, if you look closely on the bucking lips, you can see that there's nicks on it. That's factory. And the nicks are also on the protrusion that enters your barrel for your BBs. If you look right there in front of my finger where the light's shining. Not a real fan of the bucking. And the barrel is a 605 millimeter. I got my little pin gauge here. It's a 604 plus. And my 606 plus obviously didn't fit in the barrel, so it's in between. So it's really good indicator that this is a 605. I personally, as a tech, I like 601 barrels because I try to get as much FPS efficiency as I possibly can, and I don't like wasting air, and I don't believe in that theory where the air supports the BB down the barrel crap. I do like that the barrel has a O-ring to keep it stabilized, so you don't need to do the tech trick of wrapping Teflon around it to center it. Here's the end. It's meh. And board quality in there, it's really hard to show on camera. But looking down at it, I just see obvious ripples, which ripples down the barrel means that you got peaks and valleys, and that ruins your accuracy. And you typically want to find a barrel or just lap the damn thing and get rid of those peaks and valleys, and that tremendously helps accuracy out, the 200-foot range. And here's the ETU that was in it. According to EVIC, this is an E-Shooter Basic. Uses a mechanical switch for the trigger. It's like a little plunger dealy dad. On the other side, you got your mechanical switches here for your semi and full auto, for your selector plate to come by and press them down. And good old CYMA's logo. Even though this says is CYMA, this is an E-Shooter. You can go right on the E-Shooter's website, get the manual for this thing, and program it, and it'll work exactly the way it's supposed to. There are some minor differences between the E-Shooter on their website and this one. Normally, right here is a connector for you to put auxiliary power to. But instead, I believe CYMA did this guy instead. They opted out on that connector right there where my thumb is, and then just directly connected a wire straight to the ETU. Positive, negative leads by my index finger and my thumb. It's not a wrong way of doing it, but I'm curious to why they went that route instead of just leaving it, I'd like to know your thoughts on it down in the comments below. This is, in my opinion, a decent ETU. I've never had any issues or heard any issues with these E-Shooters personally. But yeah, I'd like to know your guys' opinions on this guy. That about does it for what's in the REC10. So let's move on to what are the upgrades we're going to put in this thing? Well, let me show you. I'm going to get all this stuff out of the way and line everything out for you. 1, a 2, and a 3. All right, got everything laid out. Off camera, I did some compatibility testing to make sure certain parts went with each other or not, and I'll go over that here in a second. But first, let's go over what parts are going in this build. Starting with Matrix M140 spring. This should easily get us to our 2.4 joule goal. For the piston, so we're going with the Retro Arms 19-tooth piston, because I don't think the OEM piston is going to survive a 2.4 joule replica in the long term. And since it was ported, we're going with the Retro Arms cylinder. I like using these cylinders for the SR25 specifically because they're a little bore up. They're actually 24 millimeters instead of the typical 23.85 millimeters. And so that gives us a little bit more air volume ratio to work with. So I like that. For the piston head, we're going with the EPS piston head, as I really like their coating that they put on these things, and they also have a backup O-ring, and because it's aluminum, that weight is going to be nice for heavyweight BBs. And there's a slot here that I'll get in a little bit what that's for, and make up for that slightly overbore on the Retro Arms cylinder, because the O-ring in this is not going to work. We're going to use an X O-ring from Airsoft Mutations. These fit perfectly, not too much resistance, and they get a seal every time. And this is not going to cycle too fast, so this is going to do a great job holding seal on the compression stroke. The cylinder head, we're going with the EPS cylinder head, and here's why. For one, they're one of the only companies out there that uses these set screws right here that makes this very universal for any version 2, version 3 gearbox. And what it does is that they push against the pins and therefore holds the cylinder head tied up against the gearbox on the front. You can set those set screws so perfect that when you put your cylinder head in, it don't fall out, and it goes in very easily, and that doesn't move up and down without the cylinder. This will help prevent mid-cap syndrome and provide more nozzle stabilization, which gives you a better FPS consistency. Because when it comes to DMRs, you want things as rigid as you possibly can. To complement the EPS cylinder head, we're going to use the EPS nozzle because this is an extra fit. It's a 24.5 millimeters in length, and it has dual O-rings that's separated for better nozzle stabilization. If you look closely on the cylinder head, the stem is a little bit longer than usual, and that's to help support the nozzle in the extended position so you have less nozzle wobble. Don't want that in DMR platforms at all, because one, it causes mid-cap syndrome, and two, gives you more FPS consistency because that nozzle is going to the exact same spot every time it cycles. And let me show you how well the nozzle stabilization is on this. So I'll extend it out. This is where you really want to test your nozzles. Extend it out as if it was in the forward position. Barely any wobble. Barely. Most replicas, especially cheap replicas, and what used to be on this, it'd wobble like a hot dog getting thrown down the hallway. Not good for FPS consistency. And as I said before, I didn't see the reason to swap out the factory tappet plate. It's more than enough to handle the job and help support your nozzle. Usually in these SR25s, the spring return for the tappet plate is more than enough and strong enough to hold that nozzle tight up against that bucking. I'm going to retain the factory spring. Before going any further, guys, if you like what goes in this build, or you want to get the parts just in general, just for yourself or your particular build, you can find all these parts on my website. Links will be down in the description below. Anyways, then we're going to be using the good old WishTech gear set made by Javon. The sector gear in these they don't have that issue of only the screws holding the two halves of the sector gear. So what ends up happening is, like for example, the SHS and Rocket sector gears for SR25s, they don't have the Tappet pickup pin, as you can see right in front of my finger. And what ends up happening is that those screws will shear, and the two halves of the gear will do this, and they'll just free spin, and then you got a crap sector gear. That's not the case on this. That and the sector gear also has a normal Tappet plate pickup pin, so you can use the layered chip of your choice. Of course, I didn't see the reason to change out the spring guide. It's fine the way it is, so it'll do the job just fine. Little fun treat as far as the hop-up goes, we're going with the Max M4A with EPS's /Payrun LED tracer unit that I custom cut the window for this hop up and just glued this in, and I'm going to be wiring it to a Skyla ETU. I got a positive and negative leads here for things like the tracer units or anything else that you would like to run with your replica. And to complement the trigger field with this build along with the ETU, I have figured out how to make the PayRun Pro Clicker work with this. And I'm excited to get this together and see how that works out. As far as the bucking goes, I'm actually going to try 2 different buckings just because this one's new to me. This is Airsoft Mutations LC bucking 65 degree. I'm going to try it against the Super Micron, both in the chrono and in the range testing, and see which one shoots more accurate and which one has more FPS consistency, and decide which ones will be better. Ideally, this one is probably going to be better because Airsoft Mutation says that these are mainly used for heavyweight BBs of 3.6s and above, and being that this is going to be shooting 4.0s and above, this should work. The Super Micron may require more hop-up adjustment to achieve the same amount of hop as this. What really is going to come down to is which one's going to shoot more accurate. And the barrel choice for this build, just a middle ground, nothing too fancy, a Lambda 01 420mm. Why 420mm? Air volume ratio with 4 gram BBs. Don't want to go any longer than this because what I've experienced in the past is either you get more air braking effect and vacuum pull in your barrel because it's too long. And I just find the 420mm be about the sweet spot for 4.0s and maybe 4.5s depending on your application. So as far as the motors go, we're going to actually go with a Solink brushless motor light. So we'll keep battery usage at a bare minimum. So it'll make the batteries last really long for a long time in this build, and not to mention the torque. But we're gonna run a 7.4 in this anyways because I don't want it cycling too fast, because as I mentioned before, you don't want your SR25 cycling too fast with a 19.2 stroke piston. Lighter BBs, it's a bit fine, but it really depends on your gear ratio and motor speed and motor voltage combination. So as far as the bushings go, you'll notice that I have a solid bushing here and 2 J-cage bearings. These are EZOs, by the way. This is a Retro Arms anti-rotation solid bushing. As you can see, I made a little dip here using my Dremel tool and glued it in. And what's nice about that feature with the solid bushing, it keeps it from free spinning in case the adhesive or whatever you use lets go. You don't have a bushing free spinning in your gearbox, which I've had in the past, no matter what adhesive I'd use. And so this guarantees that that doesn't happen. It's actually one of my #1 reasons why I don't use solid bushings. But anyways, and the reason why I use EZO bearings, J-cage bearings, is because one, it greatly reduced friction, and it's usually more concentric, and the gears sound amazing with using these J-cage bearings. And going back to the hop-up unit, I plan on using the Max's piece right here that's usually used for the round nub for the hop-up tensioner. And we're going to use the Maple Leaf's black tensioner nub. This is about an 80-degree nub if I remember correctly. I find it the most compatible with the Super Micron bucking and hopefully for the LC bucking, because it fits nice and tight inside there first of all, so it keeps it nice and centered, and that's really important when it comes to rigidity and making a DMR, so that your application pressure to the BB for the backspin is in the same exact spot and the same amount of pressure every time. And using a stiffer nub is better for heavier BBs, because too soft, you'll turn up your hop up a lot more to get the hop that you desired for your BB. This reduces the amount you have to turn up on the dial, basically making it more sensitive. So we're adding weight to the piston to create more joule creep for 4 gram BBs, so we don't have to use an M150 to get like 2.4 joules. So this allows us to use a lighter spring, and EPS makes this perfect brass ring that fits right inside there. I mean, look how perfect that fit is. Then we'll just take the Retro Arms piston and attach it. Another thing with the builds that I do, this is more of a tech preference, but a lot of people are like, oh, I want to do AOE correction and stuff. I personally don't like doing that because that reduces your air volume ratio depending on how much AOE correction you do. Because what ends up happening is that when you do AOE correction, you reduce the amount of stroke of the piston, because you're moving the piston back and that piston head stays in the same spot. So now you just reduce the stroke. You just reduce the stroke by that much. And that much makes a big difference on how long of a barrel you can use with a heavyweight BB like 4Ls and above, and you want to get as long as a barrel as you possibly can without dropping joules. That was a lot of information that I just put out. Hopefully I didn't miss anything, but if you guys have any questions about an SR25 build, you can join the WishTech Community's Discord channel down below, or you can just ask in the comments below, but it's best to just join the Discord channel for more complicated questions. But as far as that goes, I'm going to go ahead and throw this together and we can take a look how things turned out, show you how the trigger came out, etc. I got it all shimmed up, and I just want to show you guys the trigger real quick. Notice I don't have the spring to it because you don't need it with the clicker. And I got it working with the Skyla. So here in a little bit, we'll have it all together and I'll show you it working. We got really good compression. I'm pushing pretty damn hard too. So we're good on the compression. I got the timing set as good as I can possibly get it. And if you look closely, you'll see that I trimmed the delayer chip. And this was just to give the nozzle more dwell time against the bucking so that we can maximize our FPS consistency as much as possible. Because Tappet plate timing has everything to do with how much FPS you gain and your consistency. Ended up swapping out the anti-reversal latch to one of these golden ones. And the spring that comes with them is really strong, so I'm pretty stoked about that for the pre-cocking I plan on programming in this thing. And which, by the way, the Skyla does an excellent job at getting the pre-cocking at the same spot almost every time, which equates to consistent FPS. So hooray! And then I got the tracer unit on the hop-up all wired up and it's working. I'll show you guys later in the video this working. Everything's all tested and ready to go. I just gotta put it all together. So that being said,
2 hours later.
Whew, that was a process. Putting that back in wasn't fun. Aside from that, this is gonna be a first impression. I have not plugged this in yet, and we'll see if I got the motor height set right on the first try. Same with the shimmy, obviously. So we're gonna do a couple test cycles and make sure that the light is shining and obviously that the trigger's working. I always do this before I actually put the whole replica together, because if there's an issue, I don't have to take the whole replica back apart again. So here we go. Time to pluggeroo. Now let's see if I got it right. Okay, so I just had to figure out its cycle detection, and that's one thing I need to do now is do the cycle detection calibration. And as you can see, the trigger is working and the light on the tracer unit is working. And the clicky click is working. Let's try full auto and listen to that shimming. It might be tight in a little too tight, so I'm gonna actually adjust the motor height a little bit to see if I actually had it up too tight, just barely. So don't always get it the first time. Sometimes I do, sometimes I don't. And the fact that it's cycling really slow, you can still hear a little bit of whine. Yeah, so I'm gonna let's do a quarter turn. Back it off a quarter turn and see how she sounds. That made it sound a little worse, I think. Let's turn it back the other way. Quarter turn, and let's do another quarter turn. See how she sounds. Oh yeah, that made a big difference. Okay, so we had to tighten it a little bit, so it wasn't up high enough. Do a little bit more. That's too tight. Back it off a little bit. Go back to where we were. Found the sweet spot. That little whirling noise is gone, so slow cycle and it sounds like this. Okay, let's go to the calibration. I do plan on running pre-cocking on this, so we'll see what that sounds like. Because right now it sounds like this. Pretty damn good. I think this is so far the best sounding SR25 I've ever made that uses the CYMA grip here. Usually these grips causes alignment issues, but so far it's the best sound I've ever heard. So the low battery indication turned off. The active braking was actually set to 70%. And I just brought it down to 9%, so let's see what that does. A little bit of pre-cocking. Let's see what 60% looks like. Oh, that sounds good. Let's run a little bit more. Let's go to 70% and see what that looks like. See what I mean? Watch that right there, and you'll see how consistent it is in that position. Oh, it's going to go a little bit further back because I just increased it another 10%. Let's see if it double cycles. Damn, that's good. So we're right at the point of piston release on the pre-caulking now. But I mean, look at that trigger response. From the time that trigger is pulled to the piston release. Yeah. Oh, that's good. Now that that's all good and it sounds great, I'm gonna put the upper receiver all together, run some Teflon tape around the barrel to get it centered and stabilized inside the outer barrel of the SR25. And we're gonna test with the hop-up off and see what kind of joules we get. I'm hoping we'll get a little bit over 2.4 joules on this, so that when you turn up the hop-up, it brings it right back down to 2.4 when the hop-up's actually adjusted. But in order to adjust the hop-up properly to where it's actually effective, I need a range to do that. So I'm gonna have to take this home and test it out in my backyard and get it there and then retest it and see where the joules drop. We'll get the joules baseline, and if it's way high, like 3 for example, we're probably gonna have to change out springs and go to a weaker one, which in my opinion is not necessarily a bad thing. It just means the system's really efficient to hit our joule goal with 4.0s. So with that being said, I'm gonna get the upper together like I said, and then we'll head over to the chrono. Okay, first things first, I'm going to do 10 shots with the pre-caulking completely off. That way we can compare if the joules drop off if we add too much pre-caulking, because that's the thing, is too much pre-caulking, you could be affecting your tappet plate timing in such a way that you're actually losing joules and or FPS. First, going to see what kind of joules we get compared to our baseline. After we get our 10 shots in, then I'm going to maximize the pre-caulking all the way up just before it double cycles. 10 shots, here we go. We're getting 2.27 joules, kind of close to our 2.4 joule area. I feel like the consistency could be a little bit better, but it's pretty decent. Okay, I'm gonna go ahead and turn up the pre-caulking all the way. I think we can get away with 73%, as you can see. Gotta set the 73%. Probably gonna take about 2 or 3 shots before it actually takes effect. I'm gonna go ahead and reset the chrono. All right, 10 shots, here we go. Okay, now it's pre-caulking. Interesting. Our joules went up a little bit. Now let's go ahead and shoot another 10 shots. And still under that 2.4 joules. I was kind of hoping that would be over 2.4. FPS consistency is about the same. Previously in the video, I wanted to test the LC bucking against the Super Macron. So I'm going to put the LC bucking and see if the FPS is any better with 4L Grand BBs.
1 minute, 37 seconds later.
Okay, I got that LC bucking installed. We were getting about 355 FPS average on 4.0s. Now let's see what we get. About the same. The FPS didn't really change that much. On the plus side, immediately tells me that the bucking isn't affecting FPS whatsoever, so it's getting the most efficient seal possible with 4.0s. And if we go here, 233, so we're almost at 2.4. Very, very close. So the only thing to check now is to see how the accuracy differs between the Super Macaron and the LC bucking. Before we continue, an idea just popped up. Curious to see if it'll gain joules on 4.5s. So we're getting about 2.33. I'm wondering if the 4.5s might gain that a little bit more where we want. So let's find out. I just put 4.5s in the mag. Hope for the best. Watch right there. If that hits 2.4 above, we're good. If it drops, that means the air volume ratio is not enough for the 4.5s. So kind of hoping it raises. Here we go. Nope, we lost joules. All right, so good to know. The joule loss is due to lack of air volume ratio. If we want that to go up, I'd make the barrel just a little bit shorter. And for funsies, let's try 3/2s to see where those joules go. No, it's not 1.6 right now because I have to actually put 3/2s in it for that to change. So hang on a sec, I'm going to put some 3/2s in.
Alrighty then.
Got the chrono set to 3/2s, got 3/2s in the mag. Let's see where the joules go. .4, son of a bitch. So why did the joules rise? Well, that's a clear indication that the air volume ratio isn't high enough for 4.0s. So what I need to do now is I gotta make the barrel a little bit shorter to get those joules up a little bit for 4.0s, because 4.0s are gonna travel further than 3/2s for the same joules. Joules to joules slow. 3/2s shooting 2.4 and 4.0s shooting 2.4. The 4.0s are going to shoot further. Probably just gonna cut the barrel about 10 millimeters and that'd probably get right where we want it to be. Okay, so I got the barrel marked where I'm going to cut it 10 millimeters from the front to back, and we'll do a little bit of recrowning and see if that does anything to our joules.
A few inches later.
All right, got it cut off. Now I'm going to switch out my tooling to get that beautiful crown.
5 minutes later.
And there we go. Got that crown. Oh, nice and pretty. Polished it a little bit too. Very concentric too. It's one of the things I really check for. Now I gotta clean the inside of this barrel because I got a bunch of crap in there now from machining it on my mill. Okie dokie. Got the barrel put back in. We got 4.0s back in the replica. Let's see if we go more than 355 FPS on 4.0s. Yeah, and it looks like our FPS consistency got a little bit better too. There we go. Right on the dot. 2.4 joules. All we had to do was shorten the barrel by 10 millimeters. Guys, let me know what you think of our results on the 4.0s on an M140 spring. Okay, let's see how accurate this guy is. Alright, that tree's about 53 yards away and a little windy out. So, let's see how things go. That tree's about 2 feet in width. Damn. So with DMR platforms, you do not want to spam semi, so that's why I'm taking slow shots with this. But yeah, as you can see, it is very accurate. Okay, so I have this theory. After watching that range test, I was like, I feel like there's something off here, and I think it's the barrel, because I've done a build very similar to this with the Silent Industries hop-up, and had great results. But in this case, I think the problem lies at the end of the barrel. So when you first get a Lambda barrel, I don't know why, but for some reason they don't do a chamfering at the end. So I went ahead and did it. As you can see, it's pretty nice. But the idea I had, this is the barrel that we were using, I already had that chamfer in the video, but I think I might have made a little tiny itsy bitsy mistake, so small that I don't think I caught it. So what I'm doing now is from here to here, I'm essentially going to lap the end of the barrel to get rid of any imperfections in my machining, especially on the chamfering here. If you look closely, there's no abrupt edge anymore. There was. I'm sorry I don't have a picture of what I mean, but you can see it's nice and smooth on that little corner there where it starts to angle down and create that chamfer. Well, I just sanded it on my CNC lathe with 800 grit right at the entrance there. And then I'm going to do a step-by-step process using this diamond powder compound. This is a lapping technique that I've seen HS Armory do in one of his videos. Shout out to him. But this is something I ever wanted to try myself for a long time, and I'm going to try it on this build to see if it makes any difference. But anyways, I'm going to go to a 1050 grit, then a 1200, and then a 1500 grit. And the goal is basically clean up what that sandpaper left and turn this into a very nice polish from here to here. And the idea is to have the end of the barrel here open up very gently and then have that chamfer right at the end to basically, when the BB's coming out the barrel, inside the barrel, if you were to do a cutout, it's basically separating like this, and then it comes to that gentle chamfer with the rounded ends there. And it's basically just to make the air that's around the BB inside the barrel here to gently part ways instead of abruptly and then bounce around and then cause the BB to deflect. So that's a thing in airsoft, and I want to test this hypothesis by doing what I'm doing here. And then I'm also going to, and that's another thing I saw with these lambda barrels, you can see some machine marks at the base of down here. And I was going to sand that out and then polish it up. And I started doing that with the barrel here, and you can see the difference. So the left one is the one I polished, and the right one is the factory one. And you can see, if you look very closely on the left one, you can see those lines. Those are machine marks. Otherwise, this left barrel would be shinier than the right one. So due to the imperfections in this not being polished, it looks cleaner than this one. And ignore these little nicks here. These aren't going to affect the performance whatsoever. What I was trying to do is round out the edges on the factory one so that it didn't cut into the bucking when the bucking was pressed down. So I do that modification, and these nicks here are not going to do anything. But I do plan on cleaning those up a little bit more to essentially deburr it. But anyways, where you can really see the difference is at the end of the barrel. So the left one is the polished one, and the right one is the not polished one. You can see a clear difference between the two. To get rid of those machine marks right there, I have to use more aggressive grit to get it down, and I pin gauge these barrels, and amazingly enough, these are under 0.601 millimeter, which is interesting. But anyways, I'm going to polish that down too and get rid of those machine marks, hopefully to help. And I'm worried that it's all the way down the barrel, but I can't see it when you look down it, so I don't have a bore scope to inspect the barrel. I may stop stocking lambda barrels because of that reason. Yeah, I'm going to polish this barrel, fix the end of it, and see if it makes any difference and just range test this. I may just swap to a completely different brand of barrel because I'm pretty upset about the machine marks after polishing that end. I was like, what the hell? Let me show you the mill and how I'm doing it. Alright, so basically I'm going to be running this at about 500-600 RPM, and I'm going to be using this dowel right here that I sanded to be tapered from this end to here, and I'm basically just going to go back and forth while it spins, and then just work my way down on the grits, and then use a different rod for every grit so that I am not mixing grits together. And I should give it a very nice, very small taper at the end of the barrel there, and see what happens.
2 hours later.
Okay, I got the lamping done. Top barrel, this is a stock lambda barrel, and this is what I did for lapping. As you can see, those scratches are greatly reduced or pretty much gone. Yeah, it was so bad in this barrel that there were rings going around and around, and you can now see that they're gone. Hopefully this does something. I'm going to throw this barrel back in and see if it's any better. So guys, I want to apologize. I looked everywhere. I can't find the footage of the range test after polishing that barrel. But I will tell you that it didn't really make much of a difference at all. If anything, all it did was make the hop more sensitive, so I didn't need to turn the hop up as much compared to non-polishing. Additionally, after I made my 10 shots or whatever, from what I can remember, the gearbox locked up. And I'll tell you why. So we experienced a lockup. We're using a 28K brushless motor on 11.1, but we're using 7.4, so that makes it cycle a lot slower. So it should give the piston plenty of time to finish its stroke before it gets picked up by the sector gear. Well, one thing I didn't take into account is hop up pressure. I think I mentioned this earlier in the video, but when you turn up your hop up, you turn it up, and it applies that pressure on your bucking, and of course you got your nub down in the barrel. BB enters, and for a very, very brief moment, it's held there when the piston inside the gearbox is released as a buildup of pressure. Once that pressure builds up to a certain point, the BB is finally released. When that pressure happens, due to the spring pushing the piston in, it's creating the pressure is going up, but during that time, it's slowing down the piston. Well, when I was adjusting the hop up higher and higher, the more of this pressure thing was happening, and it ended up slowing the piston down just enough to cause premature engagement and locked up the gearbox. And just before it happened, it was sounding a little weird, like a clacking noise instead of a normal piston slap noise. So with that all being said, I'm going to go ahead and open up the gearbox and take a look inside and check everything inside the gearbox and show you guys what I find and fix anything if there's anything broken, cracked, or damaged from the premature engagement, and then pull the motor out, because on these light Solink motors, if you take the cap off of them, there's a switch underneath the end bell cap, and you can switch it to a lower speed. And I'm going to do that with this one, and hopefully that it'll slow down the cycle rate enough of which the gears spin to give the piston enough time to get all the way to forward position with the hop up turned up. Right now I have the hop up turned up and left as such, where I was getting the result of the BBs going flying straight and well over 200 feet, so that I can test it again where the hop up is currently set, so I can see if it's cycling slow enough. I'm going to go ahead and tear this thing apart and take a look inside. So good news, no bad news, just good news. Nothing's broken. One good tall tale sign that your replica is premature engaging is simply look at your piston, specifically the teeth. If you look right here, you'd see some shiny marks on the teeth. This is caused by premature engagement. So what's happening is that your sector gear basically going tooth to tooth like that and then racking off like that. And sometimes it'll grab here, sometimes it'll grab there, or sometimes it'll be literally just like this. Like they're trying to stack on top of each other, tooth to tooth, leaving you that mark. And what that ends up doing is pushing the rack really hard into the piston, which on most pistons, the plastic will break right above the rack, leaving cracks all the way down here, or they'll break on the guide rails right here. You'll see cracks right here going down the inside of the piston. But this retro arms piston, nothing. I inspected it real close. I didn't see any cracks in there. I tried to show a light in there to get it on camera for you guys, but it just wasn't working out. But just take my word for it. This piston is perfectly fine. It just marked on the teeth right here. And if you have a plastic piston that locks up the gearbox, that's a strong piston. Like, holy shit, that's strong. Because it takes a lot of strength for a plastic piston to stop the gears, especially a brushless motor, in a premature engagement. So I'm actually glad it just locked up. Because I'd rather have it lock up than the piston giving out. Which in a lot of cases like this, the factory piston, that would have gave out. That rack would have punched right through and ruined it. Now, if you notice my cylinder here, enough of that premature engagement. If you have any other questions about premature engagement, just ask me down in the comments below. Or reach out to me in Discord. But other than that, if you notice these two black, this is tape on both ends. So why is the tape on there? Well, I've noticed that the cylinder was wobbling around there, and this is to basically shim the cylinder nice and centered to keep it from moving around while that piston's going back and forth so it's not wiggling. Additionally, when I took this apart, the set screws in this EPS cylinder head, the set screws either backed off or something, because earlier in the video I showed that these I had the cylinder head set perfectly in the gearbox where they wouldn't fall out, had enough grip, and they're nice and loose again. So I redid it and it's back in place and good to go. When it was loose like that, it was causing the nozzle to wobble again, and it's another reason why I shimmed the cylinder, because when I had it in here and I'd move the nozzle, the cylinder would move around while the gearbox is closed. So I was like, that ain't gonna work. Anyways, I throw this back together, I'm gonna take this cap off. I'll show you guys what the switch looks like, and I'll flip it over and get everything back together. Okay, that's the switch right there. I flipped it over and I got curious how much of a change in RPM with the 7.4 LiPo that it made. And I was using this digital tachometer, and without flipping the switch, it was just over 19,000 RPM. When I flipped it the other way, it dropped down to just over 15,000 RPM. So hopefully that 4,000 RPM decrease will give that piston enough time to get to the forward position, that what I like to call air braking effect on the piston. But I'll have to put it all together and shoot it into chrono and see. So I'm going to go ahead and throw this together, and then we can go into chrono and see if she'll lock up or premature engage. Okay, let's see how she shoots now. I did not adjust the hop up. I left it as it is when I was testing it when it locked up. So here we go. We're going to do 10 shots and see if it happens. Sweet. So far, so good. Each shot sound exactly the same. Running at 2.08 joules. I might throw in a spring spacer to get that right back up. So let me do that real quick. All right, just added spring spacer. So let's see what we get. Sweet. Yeah, we gained a little bit more. Might add one more spacer just to get at as close to that limit as possible. So that might give us another, I'd say about another 10-15 feet of range if we add that one spacer. So I'm gonna go add one more and see where that takes us. I just added another spacer. See what we get now. We're starting to get diminishing returns, but I think I'm gonna go with the 2.3 joules. It's interesting that the FPS was going up and up. Oh, I just ran out of BBs on the mag, so I'm gonna reload the mag and shoot another 10 shots to see if the FPS changes. Okay, let's do those 10 shots again and see where the FPS goes. FPS consistency is not bad. Random 354. Don't like that. I'm gonna do another 10 shots and see what that does. Okay, I think I have the pre-cocking up too high. I'm gonna try that. So right now I have it on 80%, so let's bring it down to 70 and see if that does anything. And the reason why I'm messing with the pre-cocking is that I know through experience that sometimes pre-cocking can affect your tappet plate timing, just the way how everything works together, and that could be what's screwing up our FPS consistency. So I'm gonna rule that out. All right, here we go. See if it gets better. That's a little bit better. Let's do another 10 shots. Yeah, we're not getting that random flyer anymore, so that's a good thing. So maybe it was a little too high. This FPS consistency is really good. So that means each BB is hitting that bucking at the same speed almost every time. So that's gonna equate to better accuracy with this type of shot. Now that we solved possibly the jamming issues, let's field test this guy. Not gonna lie, guys, after doing those shots at that tree, I wasn't happy with what I was seeing in terms of accuracy. So I started brainstorming and I tried the maple leaf 70-degree bucking and shit just wasn't working out. The next thing I ended up doing, and this has all been off camera and I do apologize for not doing it because I just went like total ADHD moment. I'll just figure it out, update you guys on what I tested off camera. So first things first is I think I came down to the fact that the lambda barrel was causing me issues with both buckings. Because once I tried this unicorn barrel that is 410 millimeters and it's a 603, I think this coating had something to do with making this replica shoot better. It didn't help the maple leaf bucking at all. Still made it shoot kind of all over the place in my opinion. I'm pretty strict on SR25's accuracy. For most people, they'll be like, oh, that's fine. That's actually pretty good. No, not with SR25s. You don't understand. So anyways, well, I started going down a rabbit hole. I was pretty happy with how this barrel was shooting, and I talked to the customer about going with an Edgy barrel so that I can compare this barrel to an Edgy barrel and see if maybe the bore diameter was something to do with it or it was the quality of inside the bore. So I'm just experimenting with a lot of things. The ultimate goal is to get that accuracy down to right dead center of that tree on every shot at 53 yards because that's the way it should be. Damn near like we're talking about a grouping like this big. That being said, another thing I thought about and I wanted to show you guys is tappet plate timing. One theory that I have never tested, and I'm going to try it with this one, is nozzle dwell. And when the nozzle should be completely forward. And you can manipulate that depending on how much you trim the tappet plate fin here. And I'll show you that in a second. So I went ahead and removed this delayer chip because, again, this was just a little experiment. I wanted to see what would happen. And I think this is one of the issues that was causing the accuracy to be not as good as I was hoping it would be. Although the chrono showed that the FPS consistency was pretty damn good, but that doesn't always mean that the BB is actually set in the right spot. So I think it had something to do with the nozzle being in the right spot at the right time and dwelling in long enough, etc., etc. So anyways, so my plan is, since I use precocking, I've been having the Skyla at maximum precocking, which is about 80%. And when I look through this window, when I had the receiver off, if we cycle this sector gear, as if it was shooting, move it down to about where I see it at 80%, which is right about there. You can see that it was like halfway in the window. That's 80% according to the Skyla. At this point where it stops for the precocking, I want that nozzle all the way forward, resting against the bucking. So I trimmed the tappet plate. This is as close to a tappet plate I could find that was like this SR25. But anyways, it had a long bottom portion of it here, which would hold the nozzle back and gently let it go. Well, in my little theory here, that's well and good and everything, but in this application, I wanted to see if that had anything to do with how the BB sets in the chamber when it's pushed forward into the bucking. So in order for this tappet plate to be completely forward when the piston's pre-cocked all the way to the rear, you have to trim the leaf here, and that's what I did here. You can see that it is much different from this leaf. I just put it on my belt sander and sanded it at an angle, so in case for whatever reason the gears decide to go backwards because the anti-reversal latch failed, it won't snap it off. It just has somewhere to go. So like let's say this is the pin, comes back, rotates, and it slides backwards so it doesn't break the tappet plate. That's just a precaution that I do, and that's why I do it that way. So it's at about roughly 80%. Another thing that a lot of people don't realize when they're looking at their tappet plate is that when your hop up is against your nozzle, it pushes your nozzle back. It push it forward, it will stop right when that nozzle hits that bucking. And that's about where I had it. So right where the nozzle is resting up against that bucking when the precocking is at its 80% margin. So by the time I pull the trigger and this starts to rotate, it is now resting against that bucking. What I used to do and not realize is that when the pin's completely out of the way and the tappet plate was all the way forward, I'd notice that, oh yeah, it's flat up against the gearbox. That's not always the case when it comes to tappet plate timing. So like I said, when you bring your barrel up to your gearbox, pushes against that nozzle, look what happens. Pushes it back a little bit, right? So that's how you know your nozzle is actually touching your bucking. But it also affects when this pin lets go the tappet plate fin and engages it. If I pull it back, you can notice, look right here and look right here. Comes forward a bit, and that changes the distance from when this pin contacts the fin here. So from here to here, that rotation here is your nozzle dwell time, how long your nozzle is going to rest up against your bucking. So if I push it back here, now there's that much more a nozzle dwell. It's not much, but it does make a difference in like high speed replica builds like shoot 30, 40, 50 rounds a second. You need more nozzle dwell time if you have FPS issues. But anyways, in this SR25, there's a lot because it starts from here all the way around here. So that's one thing I'm really testing here is to see if there's such a thing as too much dwell time. And we're going to find out through the chrono as well as the accuracy test on the run cam. So I'm going to be putting this all back together, and hopefully I shouldn't have any misfeeding issues by removing this chip because I make this cycle so damn slow. I tested the motor speed with no load. The motor is literally going about 15K, and that is mainly to avoid premature engagement with the air braking effect of heavyweight BBs in such a long barrel like this 410. Even though it's a 603. It's even worse when you go to a tighter bore barrel like a 601. You get more air braking effect where it slows down the piston. When that piston slows down, due to whatever reason, this gear is going the same speed as it did on the last cycle. And sometimes what happens is that it'll catch it early, and then you get that noise and ruin your piston, or you get a lockup. And so that's why previously in the video I slowed down the motor, because that was happening and the motor was going about close to 20,000 RPM with no load. I think that's about sums everything up that I'm talking about on updating you guys on what I've done so far. I didn't record everything else because one, it would take me way too much time to figure all this out, and two, I don't remember what number 2 was. and I'm going to keep the unicorn barrel on this until I get the Edgy barrel in, so we can do a comparison on the FPS as well as the hop consistency. Before we go to the chrono, I almost forgot to mention that I did swap out the O-rings. We had this X O-ring in there because I think it was also contributing to FPS inconsistency to this O-ring. Seems to be just the perfect size for that retro arm cylinder so that the piston like moves smooth as butter and doesn't pull vacuum when it comes back on its cycle, so it doesn't tug on the BB if the BB hasn't exited the barrel yet. Now let's head to the chrono. Alright, so I got 4 gram BBs in, and I do have the hop up set to about where it was when I was testing out in the field. So I'm trying to keep this as realistic as possible. We're going to do 10 shots and see how the FPS behaves. Okay, something's weird. Like a good weird. That's more FPS than the 601 barrel that's slightly shorter. And this is a 603 barrel. Normally, with a tighter barrel, you get more FPS. And in this case, we should be getting a lot less FPS than compared to our base result when we did the upgrades and the Lambda barrel. The fact that I gained this much FPS, 360 versus 351.8 average FPS with the Lambda barrel. The only things we changed is obviously the barrel. The bucking's still the same hop up. The O-ring's changed, and I think that's what improved it. The O-ring, because it is now not pulling vacuum where it was with the old O-ring, the X O-ring, and this new one. Look at that FPS consistency. One thing I really want to test to see if it really is the O-ring. So what I'm going to do is I'm going to switch back to the Lambda barrel. It's about the same length, 410 millimeters, and it's a 601. If the FPS goes up more, this tells me that the O-ring was causing issues. And also, I kind of wish I would have done one thing at a time. The nozzle dwell increase probably helps with that FPS consistency. So let me go swap that barrel and re-chrono it.
1 minute, 37 seconds later.
Alrighty, so I got the Lambda barrel back in. It's a 601 barrel versus the 603, and the hop up is still set at 6. I tried to put it back exactly the way it was on the last chrono. Okay, so let's see what happens. We'll do 10 shots. Compares apples to apples. 4 gram beers. Here we go. Weird. FPS should have went up, not down. So something is in play here. Let's see what happens when I turn down the hop up a little bit. So I'll show you where I turn it down. Just a tiny bit, not much. Do 10 more shots. So I think the coating in that barrel might have something to do with it being smooth, because I do know that lap barrels and coated barrels are slicker inside, so less friction equals more FPS, because when the BB is going down the barrel, if there's friction in there, it's going to slow it down. So I'm wondering if this Lambda barrel is just shit. But yeah, that's interesting to see about a 5 to 10 FPS drop going to 601, which blows my mind, because a 601 will trap more air behind the BB, and you would think it would utilize more of that air to get out the barrel and accelerate. And it should, in theory, go higher in FPS. But I'd like to know what you guys think, and wait for that Edgy barrel to show up, and we can do some more testing together.
1 eternity later.
Okie dokie. So the Edgy barrel finally came in. We got the 601 by 455 millimeter. Previously, we've tried the Lambda. We ended up cutting it down from 420 to about 408 millimeter, almost the same exact length as the 410 millimeter. As the chrono results showed, weirdly, the Unicorn got slightly higher FPS than the Lambda barrel, despite of the Unicorn being a 603 millimeter bore versus the 601 millimeter bore. One thing I forgot to check was that they actually confirmed the bore size. So that's what this part of the video is going to show, and then we can chrono and test the results with the Edgy barrel. I'm currently going to leave it at 455 millimeters. That's what the Edgy barrel is, just to see what the results are with the 455. If the FPS drop, then I'm going to try it and cut down to length to a 410 to get more of an apples to apples comparison. Here's my 603 millimeter pin, my 602 millimeter plus, and my 601 plus. And then to check for a 601 barrel, I have my 6 millimeter, exactly 6.000 millimeter. Starting with the Lambda barrel, I'm going to grab my 601 plus, see if it drops in. Now, if it goes in easily, that means it's a bigger bore than a 601. Okay, not going in. So that's a good sign. That means this barrel truly is a 601. So I'll grab my 60000. Oh yeah. Okay, so it is definitely a 601 barrel. Now let's go to the unicorn barrel and see if it's actually a 603. So I'm going to grab my 602 pin and see if it actually is a 603. Now it should easily go in, and it does. I don't anticipate the chamber side being. Okay, so it's probably struggling to go in on this side because I need to clean the barrel. Yeah, it drops all the way down to the hop-up window. So I was suspecting that this might have been a 601 barrel when it was advertised as 603, but it's clearly a 603 barrel. Yeah, even the 603 just drops in really easy at the bore end. Let's see if it drops down. Almost. So it could be stopping because it's a 603 plus, meaning that it's slightly oversized 603. So it doesn't surprise me that it did stop in the barrel a little bit. And this is the Edgy barrel. Nice and polished. Very pretty. Let's see if I can get my 601 plus to go in. So this pin should not go in if it's truly a 601. And nope, won't go in. It's a good sign that this is indeed a 601 barrel. Here's my 6000 pin. This one should be a little tricky. Here we go. Ooh, that's smooth. It floats. You know when a barrel is very high quality when your pin just glides in. I could feel the difference putting the pin in this barrel versus these two. Because Edgy laps their barrels. So we confirmed the bore sizes. So I'm just kind of surprised that the unicorn barrel had a higher FPS than the Lambda barrel. So let's go and chrono with the Edgy barrel and see what kind of results we get. Okay, so just like everything else, I set the hop up to as close as to the other ones as possible. Okay, so let's do 10 shots and see what we get. Okay, so I'm a little surprised. We gained a little bit more FPS, and our FPS consistency is just insane. I mean, look at that. The first shot didn't count. That 361 always has that happen to me whenever I load it in the mag, but after the first shot, I mean, this is ridiculous for an AEG. Are you kidding me right now? So I'm going to go ahead and turn off the hop up and see what we get, and we should see a rise in FPS just a little bit. Let's find out. Yeah, okay. I mean, you'd think the FPS would have dropped off with the barrel being much longer, but I mean, it's still a 455 barrel. Okay, so I have some theories on this, on why we were getting the results that we were getting. First of all, the FPS increase between the Lambda and the Unicorn and now the Edgy barrel, I think it has to do with the internal friction of inside the barrel. The Lambda barrel from earlier didn't have as much a smooth surface inside the barrel as much as the Unicorn and obviously the Edgy barrel, which is lapped and it's a mere polish. So friction is more likely the culprit to why the FPS is lower on the Lambda versus the other two, and why the FPS increased even further with this barrel. And granted that across all three barrels we were using the same exact bucking and hop-up unit, so nothing else changed except for the barrel itself. Now, as far as the length goes with the 601 and why the FPS still increased with the 4Os, one thought that comes to mind is, and this is from experience, when you go to a stronger and stronger spring, I've noticed that joule creep is more noticeable above 2 joules. And the higher the joules you go, if your bucking can handle the higher joule rates and hold that seal in there because, you know, air pressure spike is a thing, you'll joule creep more. Not just with air volume ratio. Air volume ratio does help in that regard. With that being said, I'd like to know what you guys think why this is happening between the barrels. So with this out of the way, let's go ahead and throw this back in that SR25 or REC10 and go back out to the range and see how the accuracy improved. Alright, this is with the Edgy barrel and the change is done. Let's see how she does in 10 shot. And I lost count. Now it's spam semi. Not impressed. Something ain't right. I don't know about you guys, but I feel like the accuracy could be a little bit better, especially at 53 yards with the DMR and shooting 4 gram BBs. So that being said, I want to try the 4 Quantum Industries bucking. I'm not going to use their nub because I'm going to use the Max Pro's metal nub. Then we can go out to the field with this hit cam and shoot at that tree again and see if the accuracy improves with this bucking, because I heard good things about this bucking, as well as making my own tests with other replicas and seeing a significant change in accuracy. If the hop is inconsistent, one other nub I'm going to try is the Maple Leaf Omega nub with the Max Pro's metal trolley, because it fits perfectly in there, and then we'll go from there. So I'm going to go ahead and throw this bucking in this guy, and we'll go over the chrono and see if our FPS changes. Okay, so I did record a before chrono with the Airsoft Mutations LC bucking, and there was no audio, so I scrapped it. So I'm just going to let you know, guys, that the average FPS was 375 with 4 gram BBs. So what we're looking for now with this 4 UAD bucking is to stay at or above the average FPS. So let's find out. I did 10 shots on the before video before I got screwed up. I'm going to do 10 shots again and see what our average comes out to be. Bucking's not holding the BBs. That's weird. So I'm going to turn up the hop up and see if that helps. Because the hop ups probably retains it. This is what happens when you run a bucking with loose bucking lips. It's going to barely turn it on. Alright. Okay, I'm going to try this again. Turn it up a little bit more. There we go. So I'm going to reset the chrono. So now the bucking, the nub coming down, is holding the BB in place so it doesn't move away from the bucking lips at all. So let's see. So yeah, we gained a little bit of FPS, but it's negligible with how much it increased. It could be literally anything that's creating this slight increase. I think it's pretty damn close to being what the previous bucking is. So with that being said, let's go out to the field, shoot at that tree again, and see if our accuracy changed at all. Alright, so here we are. Tree again is 53 yards away. Got everything dialed in. Here we go, 10 shots. Damn, that is pretty damn good. So 53 yards, 156 feet. And that tree is about 1.5, 2 feet wide. So that's pretty damn accurate from that far away. Holy crap. Yeah, that's pretty damn good. Okay. So the results are a lot better, but I feel like it could be even better than what we just saw shooting at that tree. If you notice, some of the rounds were dead on for quite a few bits there, and then all of a sudden it'll start shooting off to one side consistently, and then back to the center, and then consistently to the left or the right, vice versa. And I think what's going on is, if we flip this guy over, grab my handy dandy flashlight, our hop up unit is moving around. I can move the hop up around. You see that? So if the hop up moves around, that means the nozzle is moving around inside the hop up. We want to keep that hop up from moving at all. We don't want it moving side to side, up and down, or whatever. We want to keep it nice and solid. Right now, it's up against the gearbox, nice and tight, so it ain't gonna go back and forth at all. So to fix the other issue that I'm just discussing, I'm gonna throw this kit in it, and it comes with these little winglets to go on the max hop up. as well as this guy. I'm not going to worry about this because this is for an R-hop setup, so not going to worry about this trolley. We're going to stick to with what we got since it's working and utilize this guy. So I'm going to throw these parts in and show you what it looks like on the hop up. So here's the piece that's going to keep it centered this way, and then the winglets are going to fill those gaps where they go into so it doesn't go up and down at all. So this should be pretty damn centered with the gearbox and nozzle. So when I put this in, I'm going to check for nozzle alignment. I'm going to shine my light down the barrel and see if this nozzle is actually still aligned dead center with the barrel, because that's really important. Let's throw this in and go to the tree and shoot at it again and see if our accuracy's gotten better.
Right, this is with the AirTech Studios upgrade for the M4A hop-up. Damn, I'd say that it's a huge improvement.
Man, that was great. I thoroughly enjoyed how accurate that was. Yes, some of those BBs shot to the right of the tree just by a little bit, but that was more than likely because the back end of the rifle isn't supported. I did have the front of it locked into the tripod, so that was more user error. So at that range, it really comes down to how you're holding your rifle and how stable you're holding it. And if you look back in the footage of the range test, you can see that it was wiggling around a little bit. So more than likely, that's why it just shot right to the tree. And most of the shots went right directly to the tree. And that's at 156 feet away. That tree is like about a little bit wider than this mat here. So to shoot that centered of that tree from that far away is incredible. One of these days, I'm going to have a set of targets set up with one at a maximum of 300 feet, because this replica can shoot that far without arcing the rifle. Is it accurate at that range? If I had to guess, and this is from a little bit of experience shooting this at the local paintball field, I don't like doing footage out there because there's too much damn wind to really get a good metric out of. But anyways, from that range, I would say about 5 out of 10 rounds, I could probably hit a 300-foot target. That's pretty incredible. At that range, you cannot see where the BB is landing. You have to use a scope to see where that damn thing's even going, just to put it in perspective. And this is confirmed with the rangefinder. But anyways, a lot of work went into this build. This is not a simple throw in the parts and go. I hope you guys enjoyed this video and learned something from it. If you have any questions or any suggestions what I could do differently in my future videos, please let me know down in the comments. I really appreciate any input you guys can put out, and if you made it this far, I really appreciate you guys watching. And I'm pretty content on how this build turned out. It's amazing. It's quiet. I'm especially blown away with how well the gears sound for a motor that I brought down the RPM, confirmed by my tachometer, about 15,000 RPM on a 7.4. And those gears sound as good as they do with pre-cocking. So if you want more SR25 videos, let me know down in the comments. That's all I got for you guys. So hope you enjoyed the video. I'll see you on the next one. Bye guys.